Hello students, in the second part of this video we are going to be looking at Rule 3. Rule 3 involves negative exponents in the denominator. Previously we looked at negative exponents in the numerator. In words, this rule says a base number with a negative exponent in the denominator is equal to that same base number to a positive exponent in the numerator. For example, if you look at the first example written on the screen, we have 1 over 3 to the negative 2 power. You can see that the negative exponent is in the denominator. To make that negative exponent positive, we're going to have to move that base number to the numerator, so we have 3 in the numerator, and change the exponent from a negative to a positive. Since there was a 1 in the numerator, we do not need to put that there because 1 times any number is itself. So we get 3 squared. 1 over 3 to the negative 2 power is the same as 3 squared. Since a base number with a negative exponent in the denominator is the same as the base number with a positive exponent in the numerator. Now let's look at this example. In this example, we have 1 over negative 5 to the negative 3rd power. If you notice, the negative sign is not in parentheses, so the base number is the 5. We have 5 to the negative 3rd power, and if we want to change the exponent from negative to positive, we're going to have to move its base number, which is 5, to the numerator and make the exponent positive, so we get to the 3rd power. Now, the negative will remain because it was not part of the base number, and we'll use a 1 to hold its value. In the third example, we see a very similar situation to this one, except that the negative is included in the base number since it's part of the parenthesis. We will take the base number to the numerator. The base number is negative 2. And it is to the 4th power. Since it was a negative exponent in the denominator, it is a positive exponent in the numerator. We do not need to have any denominator since we moved all the numbers from the denominator to the numerator. Now, in this last example, we have 5 in the numerator. The 5 will remain in the numerator since it is not a 1. 5 times the number gives a different value than 1 times the number. Now, since we have a negative exponent in the denominator, we will have to move that to the numerator, meaning up with the 5. So we will put times 2. We moved the base number from the denominator to the numerator, and in the process we are changing the exponent from negative to positive. So this is the same as 5 times 2 to the 3rd power. Algebraically, the rule is if you have 1 over a to the negative n, some base number to a negative power, it becomes that same base number to a positive power when we move it to the numerator. Let's practice. Let's say we have 1 over 2 to the negative 8 power. Here we have a negative exponent in the denominator. Since we have a negative exponent in the denominator, we are going to have to move that base number and exponent to the numerator to make it a positive amount. So we'll have 2, and we will change the exponent to a positive. This is the same as 2 to the 8th power. Here we have 1 over negative 4 to the negative 5th power. Notice the base number is negative 4, so we will keep it in parentheses, move it to the numerator, give it the positive exponent. Negative 4 to the negative 5th power in the denominator is the same as negative 4 to the 5th power in the numerator. Let's do 2 more examples. We have 1 over negative 3 to the negative 3rd power. Notice the negative sign is not included in the base number. The base number is only the 3. So we move the 3 to the numerator, making the exponent positive, and we leave the negative in the bottom, and we give it the number 1. So 1 over negative 3 to the negative 3 power is the same as 3 to the third power over negative 1. Last example, we have 4 over 2 to the negative third power. The 4 will remain in the numerator because it has a positive exponent of 1, which means it is in its simplified position. We will also have to move the 2 to the numerator with the 4, changing its exponent from negative to positive and putting a multiplication sign in between. So 4 over 2 to the negative third power is the same as 4 times 2 to the third power. Let's now try some algebraic examples. If we have 1 over a to the negative n power, we move the base number, which is the variable a, to the numerator and give it the positive exponent. If we have 1 over negative a to the negative n power, the negative a is the base number. It gets moved to the numerator with a positive exponent. If the negative is not part of the base number, such in this example, we only move the a to the numerator, give it the positive exponent since we move from the numerator to the denominator, and leave negative 1 on the bottom. Last, we have b divided by a to the negative n. The b has a positive exponent of 1, so it will stay in the numerator. A to the negative n will move to the numerator and become a to the n power. So we have b times a to the n power. Now, there are combinations of properties. A combination is an expression that contains more than one rule that needs to be simplified. To simplify a complex expression, remember, think how many exponents each part of the term has. Draw a fraction bar to help you distinguish the numerator from the denominator. Eliminate any zero exponents because they equal 1. And last, only move the negative exponents. Positive exponents can stay where they are. Let's do some examples. In this term, we have 2 exponents. We see negative 4 is k's exponent, but 3 also has an exponent of 1. We don't have to write the exponent of 1, but it is important to think about it as being there because 3 is a simplified expression. It does not need to move from the numerator to the denominator or vice versa. So our second step is to draw our fraction bar. Eliminate zero exponents. We do not have any zero exponents, so we'll skip that step, and we will only move negative exponents. So if you look at 3 to the first power, or just 3, it has a positive exponent, so it's going to stay where it is. We're not going to move it. However, k to the negative 4 needs to have a positive exponent, so we will move it from the numerator down to the denominator. 3 over k to the 4th is the simplified version of this expression. Let's try another example. 1 over 2b to the negative 3 power. How many exponents do we have? Well, we have 3 exponents. Here's 1, 2, and 3. We'll draw a fraction bar. We will eliminate any zero exponents. Do we have any zero exponents? No. So we will move negative exponents. Here is our negative exponent, b to the negative 3 power. Since it's in the denominator, we'll need to move it to the numerator and put b to the 3rd power. Now, the 1 needs to stay in the same spot, but if I write 1b cubed, that's the same as just b cubed, so I don't need to write the 1. The 2 to the first power, since it has a positive exponent, needs to stay in the denominator, so I'll write 2. b cubed over 2 is the simplified way of writing this expression. Negative 5 x to the negative third power. How many exponents do we have? Well, we have 2 exponents. The 5 has an exponent of 1, and the x has an exponent of negative 3. So let's draw our fraction bar so we can distinguish the numerator and the denominator. We'll eliminate any 0 exponents. Well, we don't have any, so we can skip that step. And we will only move our negative exponents. Negative 5 to the first power has a positive exponent, so it will stay on the top in the numerator. X to the negative third is in the numerator now with a negative exponent, so we will move it to the denominator and give it a positive exponent. This is the simplified version of negative 5x to the negative third. Let's try 2f to the 0 over 7g to the negative 10. Now, think about how many exponents we have. We actually have 4. 2 has an exponent of 1, f has an exponent of 0, 7 has an exponent of 1, g has an exponent of negative 10. We will next draw our fraction bar to help us distinguish the numerator from the denominator and eliminate any 0 exponents. We can eliminate this because it equals 1, and 2 times 1 is just 2. We will keep all of our positive exponents in the same position. So we'll keep our 2 and our 7 where they are, and we will move our negative exponents. G to the negative 10 is in the denominator, so we move it to the numerator, giving it a positive exponent. 2g to the 10th over 7 is the simplified expression. Let's try one more combination. H to the third, k to the negative 1 over 6m squared. Ask yourself how many exponents. There are 4. The cube, the negative 1 power, the 1 power, and the square. Draw a fraction bar distinguishing the numerator and the denominator. Keep your positive exponents in the same location. So h cubed stays where it is. Move the negative exponents. So k is going to need to move to the bottom and be k to the first power, or just k. 6 will remain where it is. We always put our constants in the front. And m squared will stay where it is since it has a positive exponent. This is our simplified form. So here we learned our first 3 rules. A to the 0 is 1, because any number to the 0 power is 1. A to the negative n is 1 over a to the n. If it's negative in the numerator, we move it to the denominator and make the exponent positive. 1 over a to the negative n, if it's negative exponent in the denominator, we move it to the numerator to become a to the n. Here's a picture that I found online of a student's work. And it actually shows you some really good examples. It says anything raised to the 0 power is 1. So any amount to the 0 power is 1. And it also tells us that to turn a negative exponent into a positive exponent, cross the line and change the sign. Kind of rhymes and gives you a good picture of what it looks like. If it's negative in the numerator, move to the denominator and make it positive. If it's negative in the denominator, move it to the numerator and make it positive. This is a very difficult skill. Please don't be discouraged. We will work on it during class. Have a great evening.